Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking a little bit about Sudoku sums. Now, quick inspiration for this video, right? I recently discovered another YouTube channel. I'll link the video that this puzzle comes from, where this video was inspired from, in the links below. Channel's called Cracking the Cryptic, that does some different puzzles, some Wordle, some Sudoku things, and I was really excited by some of these Sudoku variants that were presented on this channel and some of the mathematics that crops up behind some of those variants. So that's what inspired this video, where we're going to take a look at one of the puzzles and only a tiny portion of the puzzle, but talk about some really cool math stuff that shows up in that puzzle. So, just in case people are not too aware of normal Sudoku rules, let's do a quick refresher there. So, the digits 1 through 9. So, we have a 9 by 9 grid to start with. And then these digits 1 through 9 appear in every row. So, any row you pick, for example, here in this fourth row, the digits 1 through 9 have to appear in some order there. They have to appear in every column. So if we look there then at a column instead, columns are the vertical ones. So if this here, column 8, all the digits, again, 1 through 9, have to appear in that column once, right? Because there's 9 digits, 9 cells in that column, they have to each appear once there. And then every 3 by 3 box as well. So if we look at a 3 by 3 box, for example, this 9th or 7th box down here, if you count in reading order, again, all of the digits 1 through 9 have to appear in those 9 cells. Even in normal Sudoku, there's a lot of interesting logical thinking that can go on, right? Okay, we use the 1 in this fourth row, it can't go anywhere else there, right? That knocks out some other cells. There's interesting questions and things that can come up that way too. But let's start looking at some of the math behind this a little bit, and then talk about the puzzle and these sums we're going to be thinking about. So let's look here then and ask the question, well, what is the sum of all of the digits that appear in this Sudoku grid? There's a couple of different ways you could think about this there. Remember that we have 81 numbers in total. They are all somewhere between 1 and 9. But we need to start using some of the properties from the previous page to think about stuff there. And just because it appeared first, let's think about a row again in this case. So what happens in one single row that we have? Well, one row, remember, has to have the digits 1 through 9. Each of them appearing once because there are 9 total digits there. So we have 1 plus 2 plus 3 plus 4 all the way up to plus 9 in that scenario. Just to quick remind you of this sum there. This is an arithmetic sequence. This could come up in some of the stuff, spoilers for later, that I want you to think about for the question of this video. First plus last, so the sum of the first and last terms is 10. Then how many terms do we have? We have 9 terms in total, divided by 2, because we are counting every pair twice, 45 there. You can think of it as, okay, we have 9 terms. The average of each of those terms is 10 divided by 2, if you like. Now, that is just one of the rows. But that works for any row. right? So when we say one row there, we're really saying that this is actually any row. For any row, they're going to sum to 45. Therefore, for all 9 rows, all we have to do is multiply this by 9. So we have 45 times 9, 450 minus 45. So this is going to be 405 in that scenario as well. So for the 9 rows, this is the total sum of all of the digits that show up in that Sudoku grid. Now, that is going to be relevant in some of the stuff I ask you to do later, but this gets you thinking about some of the ways you could look at these sums, or possible sums, things like that as well. Now, let's get to the puzzle at hand, and this will start to show you what's amazing about some of these variants and stuff like that as well. So, right, first of all, we do have normal Sudoku rules. So, for example, every row has all the digits 1 through 9. Every column has all of the digits 1 through 9. Every 3x3 box still has all of the numbers 1 through 9 there. But we have a few extra things here, actually a lot of extra things here that allow this actually to be solved. Even though this is a totally empty grid, you have enough information to find one unique solution to this, right? That's pretty amazing if we think about it, and we'll start to see how really mathematics is the key to getting started on this, and then some of the other Sudoku rules and stuff like that take over. So what are the rules of this puzzle? Well, first of all, and this isn't going to be super relevant for our video today, the 2x diagonal. So introducing a little bit of notation. We have this 2x down here scenario. So I think that's a little bit cut off. So let's not worry about that there. That 2x diagonal is going to be all of these cells in this diagonal. So this cell, all the way up on that diagonal, left to right, going up there. So all of those cells, if we add them all up on that diagonal, that's going to be twice the x cage. So I do want to just make sure we have all of the rules for this, even though some of these aren't super relevant for the portion I want to highlight. But this word cage will show up. So we see these little dotted lines, those form cages in this grid. So this 2x diagonal, if you sum up all of those values, it's twice the sum of that x cage value there. Now, right, next clue, and like I said, these aren't going to be super relevant until the end, but if we look at this domino here, it's sometimes called, these two cells, the left cell is larger than the right in this kind of 2 grid with the greater than sign there. So the number you write in the left cell is greater than the one on the right there. Now, let's start here getting into the crux of the math stuff and what I think is really beautiful about this puzzle. So we have these different cages now. So we have cages there. So for example, let me look at some of these cages with 4 cells in them. We have this one up here. We have this one here, hiding behind me a little bit. We have this one down here, and we should have one more of these as well. We have this one right here too. All right, so those, if you add up the numbers in those cells, they're all going to be different in that case. They're all going to be different there. right? And this works regardless of the size. So we have a few small ones here as well, right? So we have a two cell cage here, 2-cell cage here, 2-cell cage here. We should have one more of those as well. I'm pretty sure if I can find it that way too. Actually, no. Yeah, we have 3 of these 2-cell cages there. And then a bunch of 3s that way too. So all of the rest actually, and this is a little bit of a spoiler for things to come that way as well. If we look at all of the other cages, all of the other cages are going to be of size 3. So there's a couple missing. That will be actually the focus of our question that we have. But if we notice here, all of these different cages are size 3 too. And this is saying that the sums have to be unique. So if the 3 numbers in one cage add up to 10, no other cages can have 3 numbers that add up to 10. They could add up to 11, or they could add up to 15, or things like that, but they could never add up to 10 again. Finally, right, digits can't repeat in cages. This doesn't tell us something for some of the cages, because they might already be in the same row or in the same 3x3 grid, but some of them, even if they go between different rows and columns or 3x3 grids, they still have to all be unique digits in that cage. For example, we could not do something like 1, 2, 1. That would be allowed by normal Sudoku rules, because the ones are in different rows and columns, the ones are in different 3x3 cells, but that's not allowed because we're not able to repeat digits in cages for this puzzle. Now, let's get into our question of the day then. So I divided this whole Sudoku puzzle into these kind of different sizes there. Let me just fix my highlighting a little bit, right? There are 2 of these cells. Our question here is focused on the leftovers. So we have these 2 cells that are leftovers, one down here and one down here, that aren't in these cages that we have, and we want to determine the values of these cages. Now, in terms of solving this puzzle, that's actually a huge clue to begin with, that you can actually find the values. You actually have enough information just looking at these cages, in fact, to find what the values of those have to be. And let me give you a little bit of a hint with how we could kind of solve some of these things and how we could do these puzzle stuff that way as well. So a couple more quote-unquote warm-up questions. Spoilers, these act as hints a little bit for what's to come in this question here. So first, warm-up / hint. What is the minimum possible sum for a 2-cell cage? Right? Well, this is pretty easy, right? So kind of if we look at kind of the minimum sum for something like that there, right? We could say, well, for 2 cells, you can think of stuff like, okay, well, we could have something like 1 plus 2 is 3. Now, if you wanted to go further, right, you could say you could have something like 1 plus 3 is 4, right, etc. You could get higher values there, but just thinking about the minimum possible sum for that 2-cell cage, well, you could have the 1 plus 2 is 3 as that smallest value. You can never get a sum of 2 or 1 there. because you can't repeat the digits here. Now, just warming up in a sense for warm up 2, if we wanted to look at this for a 4-cell kind of cage there, right? These 4-cell cages, well, the smallest value, of course, again, with no repeated digits, here would be 1 plus 2 plus 3 plus 4 is 10. You could get larger values, but that's kind of the smallest you could do in there. And you might need to think about some larger values for the question. That's another mini hint here as well. But let's think here about these 3-cell cages. And I'm going to ask a slightly different question here. And this is something that can come up in different mathematical concepts there as well. I now want to ask how many different sums could go in a 3-cell cage. So, thinking about what we just did, right? What is the minimum value we could have, right? The minimum value is similar to what we just were talking about. 1, 2, and 3, the 3 smallest numbers. So that would be 6. What about the maximum value? The maximum value here is the 3 maximum numbers. So 7 plus 8 plus 9 is going to be 24 in that case. So here we have a maximum of 24 as our number there. And, right, how do we determine from here the number? Well, it should be pretty clear that, right, and let me put this as a note, right, 7, 8, 9, 10, all the way up to 23 are okay. These are all possible. 1 plus 2 plus 4 is 7. 1 plus 2 plus 5 is 8, right? 1 plus 2 plus 7 is 10. You can get all of these numbers. 6 plus 8 plus 9 is 23. We can get those values here. So, how many do we have then in total? There are, and this is a good counting trick, right? 24 minus 6 plus 1. We want to count those boundaries there. We are going to have 19 sums in this scenario. We have 19 different sums that are possible in this case there. Okay, so if we think about this then as our hints, go back to the grid, and the thing I'll leave you with as a hint for that question again, when we go back to that grid, how many 3-cell cages are there? And then start thinking about minimum sums, maximum sums, our initial warm-up of the total sum of all of the numbers in the grid, and that's going to lead you to the answer to that question that was posed. Now, we will revisit and answer that question next week. If you have thoughts about how to solve it, let us know in the comments below. Otherwise, hopefully you enjoyed this video, and I will see you all next time with the solution to that question and talking a little bit more about these Sudoku puzzles. Goodbye, everyone.